So I have a red dot, which means OBS
Okay.
is happening.
Yep.
Let's see, I will get. I guess I should have left that thing on there.
Yeah, I'm getting an ad on Twitch right now.
Well, I mean that may mean that something is happening there. All right. So if I go
Yeah.
to
Okay.
myself,
Yeah, it's playing now. You're live.
sweet. It says one. All right. Stream info. What does my phone have to say about it? This is not stellar on my phone. I've never tried the Twitch app on my phone before, but it says that I can like change the name of stuff. Hey, look at that. Data structures in Rust. Oh, I guess I'll keep the name the same. It says I'm in chat. And try and stream chat. I'm live. Cool. If I put in like hello, then it went in there. Great. I don't.
You went in there.
It went in there. Great. Yeah, I can't actually see the video from my phone. That's a little weird.
Yeah.
I would have expected it to maybe do that, but maybe it just
I bet
doesn't.
I bet I can see it on my phone.
If I search for myself, maybe it doesn't want me to watch myself.
Yeah, maybe.
But either way, I guess as long as you can see it, that's kind of the key thing.
Yeah. Yep. Looks good to me.
Okay. So let's go ahead and make it so our tests run again.
Yeah, with enter.
Yes, I was going to use that enter again. So if I do Ian or find all my source files, and then I pipe those into enter and send them to cargo test. And I only want my test, not my doc test. And I'll make it quiet so it doesn't show me all the warnings in there, so it's a little more compact. So we're in a good state right now. And I think I just heard myself talking from your phone.
Yeah, that's right. I'm watching on my phone now.
Okay, excellent. Then let's talk about where we're at. So last time we were working on making a linked list, and we have a whole bunch of things that are happening. We've got peek, push, and pop, kind of the stack type things, and those seem to be working. And I think this time we were talking about doing an iterator. So
Iterator.
yeah.
Yeah,
So
something like that. Something about going to the next one or something.
yeah. So if we go ahead and write ourselves a test of test iter, then to give you an example, if I say let I don't know, like my vec, which is a new vector, and it's got 7, 10, 12, sure, or 15, sure. And one thing you can do with a vector is if you want to say kind of stream over it or map over it, you need to do it on an iterator of it. So a vector itself is not iterable, but it can produce an iterator. And so the way you can do that is you could say let mutable, because I'm going to make an iterator, let mutable iter is equal to like myvec dot iter, which gives back a new iterator out of it. So here it'll say that, maybe it'll tell me the type of it. I don't. Why is it not doing that? I'm not sure. But the type of it is an iterator. And if I go to Chrome and open up Rust docs, because we're going to need these anyways, and I go to the top level docs and search for iterator. An iterator is something that has next on it.
Okay.
Hey, this looks very similar to what I'm doing right now. So an iterator is just a type that, or a trait that requires next to be implemented. And then if you...
So it said it was an interface, right? Is that the same thing as a trait?
It's similar. So the difference between like an interface and a trait is that like a trait does not have to be implemented on the base class, like when the base class or base struct is created. So you can go and implement iterator on anything if you wanted to. Like, I mean, say you had a file object or something like that and you wanted to implement iterator on it, you could do that.
Okay.
The requirement is that you produce a next.
Okay.
So what we can do, I guess finishing kind of the example here, is that our iterator, we can go and assert equals that iter.next, and I'll unwrap it because it is a option, because iter next always produces an option of something. And then I would expect that to be 7.
And an option is basically a maybe?
An option, yeah, it's like a maybe. So an option can either be some or none, as we worked with in the past. So when we were popping off of our list, when the list was empty, we were giving back an option of none.
Yeah.
So same goes for an iterator. You just keep calling next until it gives you an option none, and then you know that there's nothing else left in there. So we can assert that it's 7, 10, and I'll go 16, and then it should fail and say, hey, that's a 15. And it seems to be mad because I'm trying to compare an integer with a reference to an integer. So iterator.next will wind up producing a can I see the type of this thing yet? It's not showing me, but it is trying to compare a reference. So the iterator for a vector gives back references, and right now it's mad because I'm expecting that it's going to be 16 when in fact it's 15.
It's not mad, it's just being helpful, right?
Well, I guess, yeah. Maybe mad is a little bit, yeah, it's not mad. Computers don't have emotion.
So if you decided to not unwrap it, you could do this, you could, on the right side, could you just put option sum ampersand 7?
So, oh yeah, I guess that's true as well. So if I could even do, yeah, sum like that.
Is it an option sum?
So it is an option sum, but option is actually available in the global. I totally spaced it when writing some of the previous stuff, but this sum is the same thing as option. So somewhere in the depths of Rust there is like use option star like that, and that makes all of the enum, all of the enum values of option available just directly without having to put option in front of them. So they're equivalent.
Okay.
But yes, that also works, and then I wouldn't have to unwrap it. Either way
Cool.
could work, I guess. But that is what an iterator does. Is it's just something that produces next. And the
Oh
other,
wait, and then you didn't do it. If you did next one more time, it would be an option of none, right?
yeah. So in which case I definitely wouldn't want to call unwrap, because if I did, then I don't know, say it was 0 or something like that. Unwrap is a way of saying, like, I know what I'm talking about. This thing is definitely going to be there, and it winds up panicking after I make it compile properly.
Panicking.
Yes. So panic is Rust's way of. So right here, Rust panicked
Rust panicked. You're
because
right.
you tried to unwrap on a none value, which is bad. So if I did want to go and assert that thing, then changing this to a none like that would make everything happy again.
I'm guessing panic is actually a computer science-y topic or something.
Yeah, that would
Kernel panic or something.
right. That would be a nice topic for us to dive into on Book Bites sometime. Is what is panic? Like, why is it called panic?
Yeah.
Like, I mean, you can certainly
Okay,
cause
so
panic.
that's an iterator, but that's not. That's just very similar to what we're actually going to do, right?
That yeah, that is similar to what we're going to do. So we're not going to do exactly that thing. I guess we'll implement it very much the same way, but we're going to implement our own iterator rather than using this one.
Yeah.
So let's see if we can do that. And I guess the other nice thing that comes with an iterator is you don't just have next. Like, next is kind of boring to call on, because it's just like you wouldn't ever really want to do this directly, or at least maybe not ever, but you wouldn't want to do it very often. But what you can get with an iterator is the ability to do like iter dot map, and you could say like I, and you could say I times 2 or something, and from that you could go and say like let I don't know, let result or something like that is equal to that dot collect. And if we collect it and say that we want to have a vec of u32 or something, I think that would work. If it maybe it'll
Okay.
expected I32 found u32. All right. If I say I32 for now. Why are you mad at me now? Value used here after move. Oh, okay. So it's just mad that I'm using the iterator, or like I'm using the iterator after it was moved, because this map moved it.
It moved it.
Yes, because the signature of map happens to take self. So
Oh.
so map, wherever it's at, takes ownership of self in its signature. Self being the iterator.
Gotcha.
So, but with that, what it lets me do is I can say that I want to assert that result sub 0 is equal to 14. So it, like, having something that implements the iterator interface gives you a whole bunch of useful methods just from implementing that one next. It lets you implement map or for each or filter, reduce, all of the things that are kind of higher level functional iterating over stuff rather than writing for loops.
Yeah. Does it also have next? I mean, in addition, next does also have previous.
It does not, as far as I know.
Okay.
There may be like a two-way iterator. I'm not totally sure, but I don't think that. I mean, it doesn't force you to do previous, so I would assume that this one doesn't make that, which works out well because our linked list has no notion of going backwards.
Right. Yeah.
Grab a drink. All right,
That
so
sounds like a heavy water bottle.
well, I guess when it hits my desk, it sounds like it. It's like a hydro flask one, so
Those are heavy.
they are heavy. They could do a lot of damage if somebody used it as a weapon. So, all right, let's scrap this because we don't really care about my Vec. And what we do want though is we want a list. So we'll take this one right here and we'll just copy it down below. So we have a list and we've got two things in it. We know that works. And we can maybe even go a little bit simpler. We don't have to put stuff into our list yet. We'll just make a simple test. If you say let my iter is equal to list iter. So that's the first thing that we need to have, is a way to go and create an iterator, right? And then from there, assert equals, because I don't know specifically what we'd assert about the iterator itself, other than we can call iter.next, and it gives us none.
So actually, I thought the list itself would have the next method on it.
So when you implement iterator, you don't implement it on the collection itself, but instead you create something that can iterate over that. So you create a structure that knows how to iterate.
Interesting.
And the reason being, or at least one reason I can think of, is that
Okay, I see. So list does have an iter method. Is method the right word?
yes, yeah. They use the term method, so right there
Okay,
it
no,
says
this
method.
makes sense, and that will return you an iterable.
Yes, that will return an iterator.
Okay.
So if we first we need to make an iterator on this, and so the way we can do that is we add a function, we call it iter, and it needs to take a self of some sort, and it gives back something that is iterable. We'll call it our iter, which is, this does not exist yet. Iter does.
It is a type. It is a type we have not defined, right?
Yes, so that's why it is red right now. And I definitely don't want it to take ownership of self, because I want to be able to create multiple iterators over this thing. I mean, that would seem to make sense, wouldn't it? And
say again.
I definitely don't want to take ownership of self, so I need to put an ampersand, because then I can call iter on it multiple times instead of giving itself up or like passing ownership.
Yeah, you never know how many times you need to iter.
Yes. Well, there is actually, I think on a vector, that there's one that's called into iter that does take ownership, which it made me understand kind of the into style of, like, when it says into, it says, all right, you are taking ownership and you're turning this thing into an iterator, and that is the end of it. Or like that's the last usage of it that we're gonna have.
Interesting.
But we're not gonna do that right now. Okay.
Into is an interesting way to name it. I would have thought it would be something like iter once.
Iter once. I mean, I guess, I don't know, maybe you could iterate multiple times. I don't know. Into is just what they decided to opt for. So, all right. So we need to produce an iter, and when we do that, this is just taking a guess at what the thing will need to do, but we're gonna have to produce an iter, right?
Mm-hmm.
Okay. And maybe we'll want to give it more stuff, like maybe that reference to self so it can actually use it. But until then, we'll make a struct. I botch that every time I type it. Iter. And
You're kind of stuck on that
yes.
typo.
And impl iterator for iter. Because we're going to need to do that, and that is going to force us to make next. So we have our struct of iter. Doesn't do a whole lot. And this impl iterator for iter is going to need to have next in there. So we'll make a function of next, and it needs to take a mutable self. That is the requirement from the naming of it, and it will need to produce a let's see. Need to give out.
So is this what you were looking up in the documentation? You're actually implementing this iterator, and it requires you to have a next.
Yes. So you see where it says required methods?
Yeah.
So the
Is that
trait
the only one?
that it has to implement?
Yeah.
Yes. So all these other things.
Cool.
Yeah.
It gives you all those other things just for implementing next. I kind of missed that. I didn't realize that we were actually going to use this for our linked list.
Mm-hmm.
Okay, cool.
So if you see in this declaration of the thing, it has a type of item. So we will have to define like a type for the thing, which I think we can figure out how to do. Type is just like the item that will come back through it. So it's going to probably be T from whatever our original linked list was.
Yeah.
And you see it's got next, which takes a mutable self and returns an option of the item. And then all of these other ones, so like size, hint, count, last, and all those, if you see like the brackets after them, those mean that those have defined bodies, or like they are already defined things that the iterator knows how to do. So we'll get all of these implementations come for free, or not for free, but like basically, like if we implement next, we get all of those other things as standard. So
nice.
Yeah. So we're gonna give self item is what we need to return out of this thing, and we will return a none. We don't have a very exciting next. And it says all right, so type item to T. I think we can do that. And then T is not found in this scope. So can I say iter of type T? This is where I'm guessing it like type system syntax.
Interesting.
Iter of T. And what does it matter about now?
What is it helping you with?
What is it helping with?
Yeah. I cannot find T in the scope on line 46. Yeah.
All right. So can I, on line 46, do I have to do it on this impl? I know that I had to do that before. Okay, that made some of that go away.
Okay.
So right here it is yelling that T is never used, which maybe it's forcing that. So if I say that T is never used, then maybe I have to put in something here. Like
just try deleting it. Do you even need it there?
Well, iter has to have a type.
Oh.
So I think I have to make this thing happy, because right down here, like iter T takes a type.
Yeah.
So I guess we'll have to do it. I mean, I know this is stepping a little bit further than I want to, but I don't know what else to do other than I guess you can do like there's like this thing called phantom data, but I don't want to put that in just to remove it. Phantom data is a way of saying that I want to take this type parameter even though I don't actually use it in any of my members. It's kind of
Okay.
it's a weird structure. I mean, do you want to do it for sake of learning?
Yes.
Okay, then let's do it for sake of learning. See if I can remember how to do it. So phantom data. So it is a standard marker phantom data. It's a zero size type that lets you mark things that act like they own a T. So you can add this phantom, which it doesn't have to be called phantom, but it is a phantom data, and it takes a T in. This ampersand tick or single tick A is a lifetime thing. We will not. I'm not going to venture off on talking lifetimes just yet, because.
Interesting.
But yeah, so use standard marker phantom data, and then I can say phantom is phantom data of T.
Can you name the first one whatever you want? Can you name it Phantom Menace?
Yeah.
Okay, perfect.
All right, so it says missing Phantom Menace. All right, so Phantom Menace is phantom data. And then it's saying can't infer type of T. Hey, look, that thing is working. All right. Oh, cool. So it like inferred it there or something.
On line 41, you have to put phantom data of type T.
Hang on. What? How do you not go out? Okay. 41. I don't have to.
Yeah.
So it's inferred. Because right here we have an iter T, and so that tells it that T is that, and so I guess phantom data is. I just have to make sure that I pass it phantom data. And let's see. So we've made that happy. Now we're just saying can't infer the type of the linked list. That's because there's nothing in it. So if I were to say that my list happens to be a linked list of type U32, then saying it's mutable, fine. All right, cannot borrow mutably. Oh. Well, that would make sense because it is not mutable. It says consider changing this to mute iterator on this line. So mute.
Nice.
The compiler, like for as grouchy as it is, it's actually pretty helpful. Once again, it's adding emotion to it because it like, really isn't grouchy. It's just doing
grouchy, but incredibly helpful at the same time.
Yeah.
Like don't do it that way. Do it this way.
Yeah. It's like, well, if you knew what I meant, compiler, just do that.
Yeah, it knew what you meant clearly.
Yeah, except for when it doesn't. Then you get into the place of like relying, like I would be relying on weird behavior just because the compiler decided that it would be that way. That would get them into some issues too. All right, look at that. We got ourselves an iterator. It's doing awesome. Yeah,
an iterator that always returns none.
Hey, well, there's nothing in our list, so like this is doing exactly what we need it to.
Right.
So, I guess I'll add another test. Test iter with something. I don't know. So now in our
with something, not nothing.
Right. So now if in my list if I do list dot push, and I push in 42 and 100, now my iterator.next should do a couple more of these things. So if I say iter.next, then I should.
So you might as well unwrap the first.
Well, I can do this too, I guess. 42. Wait. I'm going to iterate in reverse. I'm making that call right now. Because that's the way that pop works too. Like peeking and popping. Because we're working off the front of
it. Yeah.
Which is okay. Like closure does the same thing where every time you add it, it goes into the head position. But it should wind up like that. Alright? Expected integral variable found integer. Really? That is interesting. Does it have to be that? Can I give?
Well, it says there's 2 errors. What's the first error?
Oh, count. Oh, it's
same thing?
Yeah, same problem.
Okay.
So can... If item is that type. Expected lifetime parameter. Uh-oh. Alright.
Oh, is the Phantom messing us up?
No, I don't think that it's the Phantom. It's in need of a lifetime parameter saying.
No, we're not going to go there. Remember?
I know, but I think it's unavoidable at this point. Awesome. Okay. So.
Is it like a good awesome or a bad awesome?
Well, it's one that I am not stellar at defining, other than like there is an implicit lifetime parameter that happens with all these things, and what a lifetime parameter or argument says is that this thing is going to live this long, and there are some ones that happen automatically, like in this pop, where in this peak is an example of one. So peak happens to take a lifetime that matches that of self automatically. So it's like this is shorthand for this. I think that'll still compile. I mean, it might give me the same.
What?
Let me see. Hang on. I'm gonna get rid of that and see if I can let the thing compile real quick. So
yeah, all this test is just no good.
Yeah, I'll comment it out. There is an ignore feature, but it still compiled it. So I was right there.
Whoa.
So
this lifetime syntax is very weird.
Yeah. So what it's saying here though is that I'm borrowing self with a lifetime of A, and
okay, so you can do a single quote and any letter there.
Yep. Yeah.
Okay.
And and just like the tick A is the indicator, like the single tick is the indicator that this is a lifetime specifier, and it's not like a generic argument or something. Okay. And what it says is that whatever thing is returned, like this thing that's borrowed right here, this T, so like if it's a number, like it'll be a reference to some number, and that is going to for sure live as long as this linked list itself, like that reference is. So that way, like what it ensures is that like that linked list will not get destroyed until like this reference is gone.
Nice. You're
So
like quantum entangling them.
yeah, and so like this is done by default for you in some cases, or like in a lot of cases, when the compiler can infer it. So like we were just talking about before, of the compiler like making decisions for us. Like this is one of those
Mm.
things that it opted to do. I think early in Rust you had to do this all the time, and now like they found a couple of cases where they can generally assume that that's what you meant to do. Like in this case, anytime you just take self as an argument, it says that's probably what you want. I will have to go and find documentation on that, on what those three options are. But that is
Mm.
what a lifetime specifier indicates, is that how long that reference lives for. So like given I'm returning it, it makes sure that these things all are like created and destroyed together. And it's possible, like let's say this peak also took um, a, we could say like if it took a B of type T or something like that, or anything else. What would it be? A B of, call it dude, right?
Okay.
Hang on. That's what it would be. My bad. Syntax. Okay. So if this took in dude, then I could also say that this right here has to match that B as well. Why is it mad?
Is it because you're not using dude for anything?
So what it's saying is that the return type is of type B, but self is bound with a lifetime of A. So I'm saying like I'm giving something that has a different lifetime than what self does, even though I'm returning something off of self, because node comes off of self.
Mm-hmm.
So that is like the compiler watching that and saying, stop what you're doing, and don't.
Don't.
But right. But if I were to go and give back like dude instead, then I think this thing might be happy. Yeah. So this becomes happy again. I mean, it's warning because of not exposing it publicly, but
Nice. I'm happy. I always want the option of some dude.
yeah. The option is some dude. All right. So that is lifetimes in short. I'm still working through grokking them well, but
Yeah. It's really interesting how it's a single quote because I don't think I've seen a single quote before that doesn't have a opening and closing quote.
I've seen it in Lisp type languages.
But it does remind me of markers in Vim.
Yeah.
Have you used those?
Um. Oh yeah.
You can mark a certain spot in a file by hitting M in a letter, and then you can get back to it by quote in a letter.
Yeah. So like that. Even though it took me to the beginning of the line, so it didn't do it.
Well, it depends on if you do single quote or double quote. One will take you to the correct column, and one will only take you to the correct line.
That's interesting because, I mean, double quote is also like a. I guess is it just using a register for it? Because
Something.
double quote indicates like what register you want to go and store something in.
Yeah, I'm not entirely sure.
But yes, marks are one of those things that I never think to use.
Yeah, they seem pretty handy, but I never use them.
I use a lot of Control I and Control O, except in here, because it just doesn't work out in VS Code. So I use a lot of Control U, Control D, I guess.
Oh yeah.
Because they're Vim emulation. All right. So let's see what I can come up with here. Expected integral variable found integer. Okay, so right here we have on this t, we want it to be like we want it to live with some lifetime that we're imposing on it, and it says use of undeclared lifetime a. And so if we say, can we do that? Does that give it to us? Is not constrained by the infiltrate, self-type, or predicates. So do we have to add one here? Just keep throwing it in until it stops yelling, and then it'll say, yeah, let's do it. Then our phantom data.
Okay, nice.
Wait, it's gonna. Wait, doesn't matter. A is never used. Alright, so can we give this to our phantom data? Maybe this will.
Now it's used.
Put it on. Unexpected lifetime. Uh-oh. How is it using it then? Oh, right. It was saying it was taking. Yeah.
Ah.
Type parameter.
May not live long enough.
What?
may not live long enough. It's the Phantom Menace. It has to. Oh, yeah, that kind of makes sense. It may not live long enough, but it may.
All right.
I don't know.
Okay. Well.
May pop up in a sequel later. You never know.
All right. So what do we got happening here? So it's no longer like erroring out on us. And
Is
it's
it
saying,
not?
well, I guess it's erroring, but it's erroring in a different case. So it's talking about mutation here. So the problem is now that we're just mutating a list, and it doesn't really like that. So we have our list right here. So if we were to go and say, like right now it's just mad that we are returning none all the time.
Yeah, it should be.
So that's like a test failure. It's not a compiler failure.
It's an actual text. Yeah, actual test failure.
Yeah, so we're progressing. So our Phantom Menace is doing its job.
Yeah.
And let's see then. If we were to go and give this iterator, so we gotta make this, because we have an actual test failure, we'll go ahead and give a list into that iterator. Maybe that's what we want to give.
Yeah, that makes sense.
I'll try and see how that works out. And a list is a linked list. And I'm just giving a reference to it. Maybe I have to do this. We'll see. Alright, so linked list. Wrong number of arguments. Expected 1. Found 0. Oh. Yeah, I gotta give it a T. And let's see. Missing a lifetime specifier. Alright. Let's do it. Missing list. Okay. So now let's go ahead and say list is self. So we'll make that happen.
Yeah.
Okay, sweet. We are compiling and our tests are running again. And our
failing.
Yeah, I mean they're continuing to fail.
Good.
But that's what I expected so far.
Yep.
So, let's see.
Because we're still returning none.
But we have a list now, and that is a good thing, because we have self dot list right here. So, let's see. Maybe what we want is not necessarily the list, but we want like the node on the list, so we can walk to the next one.
Yeah.
Because our mutation, because I just stopped for a second and I was like, okay, what are we doing to keep track of this iteration? And like, because this struct has to have some notion of like, how do I know what thing to get next, right?
Right. And if it has a single node, then that keeps track of it automatically.
Mm-hmm. So let's do that instead.
Yeah.
Instead of giving a linked list. And so we'll give it a node. And so it'll be
But the
self.
node will be self dot head.
Yes. Which, what is self head?
Or did we have a first?
No, we don't have a first.
Okay.
Um, yeah, I think we just left it as head. So that will be an
Head
option of node T.
head will be the last thing put on the list.
Yes, it'll be the most recent thing put on the list, I guess.
Most recent thing put on the
Yeah,
list, and it
yeah.
points to the previous thing you put on.
Uh, yeah.
Cool.
So if we give it that, so we give it self.head, then if we say that this will be node then, and it will be a node of T. Oh wait, it will be a option node of T, because it might be one, it might not be.
Might be a node of T.
Yes. And here, what does it matter? Oh, it wants a reference to it, not because we're not actually giving it away to it. Look at that. We're failing again.
Nice.
Feels good to fail, doesn't it?
Yeah. I want to see it go green though.
Yeah. Well, but we'll get there. We'll get there. So we've got this next here, and we have a node that's on there. And so what we can do is we can say that we want to, if we say self dot node, and we want to take it, right?
I don't.
Yeah. What do we want to do with it? Because we want to.
I don't know what take is.
So take.
It has a next on it, right?
It does. Well, we have to unwrap it though. Like that is one thing. It's because
Yeah.
node is an option.
Yeah.
So.
But we can't just unwrap it if it happens to be a none.
So yeah. So if we do self.node.take, because this is kind of like we did above here, where we needed to pop, because it's basically the same thing as that, except we're returning it. Right? I mean, yeah.
All I heard is it's basically.
Oh, Discourse did its cutting out thing.
Mm-hmm.
So if we want to go and get it, like our option would be that we return self.node.take, which means we're going to go and swap out the guts of it for empty.
Oh, right.
Or a none, I guess. And then we can map on top of that. That gives us ownership. And that gives us our actual node.
Mm-hmm.
And with this node, we can say self.node is equal to next. Or node.next, right? I think.
Yeah. Is next. So next is going to be a pointer. Wait, how's that work again?
Next is going to be a pointer. Oh, yes.
And so that's not actually a node. It's just a pointer to a node.
Yeah. Oh, we had to do this thing too, where we did the dereferencing.
Yeah.
So it is very much like we did in the pop.
Mm-hmm.
So let's go ahead and we'll do that. Instead of head, we'll say node. And then we'll return that value. Expected reference.
Types.
All right. So expected reference found. Can I do that?
Hmm.
Why is it mad here? Cannot borrow content from self.node of immutable. Value does not live long enough.
Consider using a let binding to increase its lifetime. Hmm.
Borrowed only until here. Oh, can I say let? Can you like that?
So explain line 60, what it's trying to do.
Line 60.
Yeah.
So on line 60, we're going and we're getting our node, like our so we're taking self.node and we're taking ownership of it by swapping it out. You've got that right? 159.
Yeah, sort of.
Okay.
The idea of swapping out is kind of weird. Is that just in case there's a none there?
So it goes and it makes sure that this node in here is one that we now own it because map takes ownership of it.
Mm-hmm.
And right here on self, this self is a mutable reference. It's not an owned reference. And so if we were to go and call this map on self.node like that, then we would
You'd be
start.
trying to take ownership, and you can't.
Yeah, so that's where we get the cannot borrow automated content. And so rather than taking ownership, we're swapping it out from underneath of it. So it's kind of letting us take ownership without actually like it's changing itself and then it returns the original. Like it changes itself into a none and then it returns a new option of sum if it happens to have a sum in it.
Okay.
And then we go and we can map on it now because map takes ownership, but it's not a big deal because like we're taking ownership of the thing that was returned from this take, not the original one, not the original option.
Mm-hmm.
But it borrows value, which is owned by the current function. To force the closure to take ownership of value, use the move keyword, move node.
Have you used the move keyword before?
I have not, but it says to do it. And the compiler is helpful sometimes.
Yeah, it is helpful.
All right. So capture a possibly uninitialized variable.
And you say it's grumpy, but I think it's very friendly. It says, maybe consider this.
Yeah. Node.value. All right. Let's see.
And have you considered using a let binding to increase its lifetime?
Alright, I put a let binding up high.
Oh, up there.
Yeah.
Ah.
Broad value does not live long enough.
Is value the one that it was talking about? When it said use a let binding? Because let already had value already had a let in front of it. It was just,
It wasn't mutable though.
it was inside the map. Oh, okay.
It says capture a possibly uninitialized variable value. Use of possibly uninitialized value. Alright. What if we were to say that this thing was equal to none? No, node. None. Initially. Okay, that changed up on me. Node value. The weird thing is though, like, this should just return it. Like, why do I have to give that value other than that?
Yeah.
So what if I were to go and do something like that?
Hmm.
Wait, that's just failing because like a syntax error or something. Unexpected token. All right. That gets me that. Okay.
Is there a formatter in Rust?
There is. There's Rust FMT.
Ah, cool.
Expected enum option found reference. That is looking closer.
Yeah. So what's it saying?
So expected option ampersand T because of return type, but it found a reference. Okay. So if I were to do that,
Someone in the chat was saying, talking about Rust FMT, saying it's also built into RLS. I'm not sure what RLS is, but
huh?
they say remove the ampersand from value.
Okay.
Oh, is that what you just did?
Yes, I did just do that.
Okay. They say you're returning a reference. It's expecting option.
I see. All right. So if I go and do this then, and I return a reference to node.value, it says node.value does not live long enough.
Really?
Yeah. And I appreciate the help, Mirapo. This is the...
So it's saying it's not long-lived enough somehow?
Right. So borrow value does not live long enough.
I really just don't understand that the concept of lifetimes yet.
And I don't know if it's because of this closure that it doesn't live long enough. Let's see. Can I do self.item? It's supposed to live A. Yeah, I don't know which one of these to really start with. Okay, so which one of them is the first error that actually happens in the list? Value isn't... Alright. latency is probably due on my part. It's probably slow streaming rate or something. I really don't know
Yeah.
how long it is because this is the first time I've had somebody talk in chat. It's excellent. But I guess the positive is we've gone this far and we haven't wound up with a black screen for 45 minutes.
Right.
So temporary value does not live long enough. So what if I were to not do this for just a moment? Cut out one of the potential problems here. So node.value does not live long enough is our issue here. Because we're just returning a reference to that. And that makes sense because we're moving and we're taking ownership of node here, but then node is getting thrown away. So it does seem like we'd have to do something like this, letting value it being a none. And then here, you say value is equal to sum of this thing. How does that work out? Or not? Can I? Okay. So if we set that mutable, does this make it a little happier? Or am I in the same place? Node.value still does not live long enough. Oh, because it's still just a reference to it. Because we've taken ownership.
Maripo says you can't. Let's see. You can't move it back out. You used move in the closure.
Right. Yeah, I see that now. But Yeah. I guess I'm starting to see like why this is wrong now, because here I'm saying move, so I'm taking ownership right here of this node with this move call. And so that is telling us that like this node only should live as long as this closure does.
Okay. Yeah, so simply return from the map. Apparently you don't need the let mute value equals none.
Okay. I mean, I guess I was trying that. It was more to like see if I could get the lifespan of it to be longer. And then
Right.
I don't need the sum or value equals sum anymore. So if I do that, then I'm still failing.
Or apparently
I don't need that either. No semicolon. But now I'm winding up in the case where node value still doesn't live long enough because I'm taking this move here. So if I get rid of that, does that put me on track? So now I'm not taking ownership of it anymore. And I'm still getting node.value does not live long enough.
They're saying node.value.clone can be one solution.
Yeah, that's if the thing is clonable, I guess. And it's gonna like yell at me to say like that's not necessarily available.
No, yeah, no method for that.
Right.
So have you tried implementing an iterator before? Or is this the first time?
I have done it on, I guess it wasn't on a mutable list. It was on an immutable one in the past. And,
Okay.
And that made life a little bit easier.
Remove the ampersand.
Remove the ampersand?
Yeah. I don't know how it's going to help, though, if it doesn't have the clone method.
Yeah, because then it's not matching the right type.
What were you doing before you were doing clone? Undo a bit.
Okay.
Okay, try removing the ampersand.
Because here, if I remove that ampersand, then it's no longer a reference that's getting returned from here.
Ah,
So that also won't work. Alright, so I'm taking that ownership of it, and how do I make that live longer? This is where I'm wondering, like, is it like a lifetime specifier that I can pull out to say like this thing should live as long as the parent, or maybe that won't work.
hmm.
So I could be working in the totally. I mean, because we've got take A. I have no idea if that's probably wrong because it's like, what are you talking about? Okay. T is of A. Let's see if I can. I know that I worked through some exercises on a site that was quite similar to what we're doing right here. Learning Rust with too many linked lists. That was one that I have done once upon a time. And they actually happen to have an iterator method in here. And it looks strangely familiar. Does that not?
All right. Yeah. Let's see. I don't think you've done that. Ampersand asterisk node?
Well, I mean, even before that, though, just simply the self.next.map.
And then there at the end, they're just returning
Is it
ampersand node value.
because
Or
I'm gutting this take?
Hmm.
Oh, well,
Yeah.
it's all okay. So they actually screw everything up and they say could not compile.
Oh, that
Like,
code we were looking at didn't
yeah,
compile?
So it is kind of cool because it works through the problems, or some of them, anyways. All right.
That's funny. Oh, there they've got ampersand asterisk asterisk like 2 in a row.
Ampersand asterisk asterisk. Oh, yeah, they're
Yeah.
like unboxing something, but it still says that it's not working out. So
A table flip.
yeah.
Another table flip. I don't know what that one is.
Next. All right.
That one looks like the table's flipping the person.
Oh, right here.
Yeah.
So this is the person like putting down the table.
Oh, okay, like putting it back. Okay.
Yeah. Okay. So I got this. Like our stuff looks quite similar to it.
Just we've been flipping tables instead of setting them down.
Right. So they're doing this like self.next.
Next as ref.
They're not doing a take though.
Yeah.
I noticed
I
that.
don't think any of the examples you said take.
Did I screw us up by doing a take right off the bat?
I don't know.
All right. No dot value does not live long enough. Cannot move out of borrowed content. What? Self.next. .map. We're doing self.node.map, which is like the same thing. Theirs is an option. Hang on. So we're borrowing an option here.
Yeah,
And they have an option with a borrowed node. That is different.
that is definitely different.
So, yeah, so we're given a reference to self head, when in fact is our head is okay. So that is probably the difference that is going on here, is that we are loaning out our option to it, when in fact that's not what we want to loan. So let's try that.
So we take an option and are loaning out. The node
So
is loaning out.
loaning out
A
is probably not
technical
the right term. No, we're like
borrowing,
borrowing that. If I do that,
borrowing a lifetime node or something.
yeah. So it's probably failing way up here now. Okay. So now what we can do is, if we have self head, then we want to let's see, can we, they had like this as ref.
Yeah, as underscore ref.
Let's see about that.
And it was saying like that was the final missing thing they were forgetting.
Yeah, so it turns option T into option, or like it takes an option and gives it back as an option reference type thing, if there is one. Which I'm yellow now. That means compiling is happening.
Yellow. What's yellow?
Yellow means that warnings are happening. So, ooh, look at
nice.
that. Do you see that? That is failing on a separate test than what we were failing on before. Oh, I'm feeling progress right here.
Which one's failing on?
So before it was failing on this one because
Right.
we were always returning none, and now we're actually we're returning. It says on the right we have 42. So now it's mad because this
Did
one
you drop
is
your keys or was that your dog?
Oh, that was my dog. He shook his collar, so, and he's got a bell on it because my other dog is blind, or going blind, and so in order to help the blind one be aware of where the not blind one is at, we put a bell on him to make him obvious. All right, we are gonna get this now. I'm feeling good, especially because we have a website we can copy from, I guess. But okay, so
Hey, yeah, I mean, next time maybe you can do it without.
yeah, I mean this is a good exercise, and like Google's there, right? I'm still a developer.
Yeah, Google's always there. Google's
So
always there.
if I say self.node is equal, and I don't remember like the other part that was going on here, and so we'll pick this apart to see if I can do it too. So if I say self.node is equal to like node.next, because it will have a next on it. Say I start there. What kind of errors?
And actually, I think this ampersand node.value goes after the map, outside the map.
The ampersand node value?
I thought it did.
Well,
I thought that was the last.
We won't have access to node there though.
Oh yeah.
And map will give us back, like it will return an option, because I mean map kind of works like it's a mappable thing, I guess. So like whatever value you return, it will continue to keep it inside that container. And since we're returning an option of a reference of T, then I think we're good.
Okay.
But all right, so it says expected reference found a box. So let's open the box.
And this isn't now an unboxing video.
All right, so we do that, and it says option. Ooh, okay. Hang on. So what did it tell us again? Expected reference found struct box. Okay. Expected.
It's a boxed box.
Yes, it is boxed box. Found type of option of that. Okay, so yeah, it's mad that the inner type of the option is wrong. So in that case, that means we need to do a map, right?
Okay.
Map of next, sure. And with that next, we'll go and open up that next.
Okay.
And then it says expected reference found struct node. So if I say this is a reference to that next thing, what's happening? Borrowed value does not live long enough here. All right.
Oh, nice. I like how it points. It lives until right here where I'm pointing.
Yeah, that doesn't live very long.
No.
Okay, so wait, this is that similar case where we need like as ref, right? Or like
yeah.
yeah, because we want to get this, but we want to get a reference to whatever's inside of it. So let's see about that. How does this work out? What's happening? Expected struct node, found struct box. All right, now we have. All right, so we have that, and now we have our node. Sorry, our next. I don't want to reuse node again. And what is next? Tell me. Let's see. We have double ampersand, so that's not good. So
is your output stuck at
Yeah, I had scrolled up. So
yeah.
Expected struct node found. All right, so I need to open this box. If I do that, still found
expected reference.
All right. So I remember they had like the double thing right there, and then I want to give a reference back out to it. Ooh, yes. Okay.
Wow.
All right. So.
That's crazy.
All right. So let's see if I can walk through this. Like we're passing, which is awesome, but now, which I once again appreciate the help. Mirupo. We got some green. So as I'm understanding, because I remember seeing the double splat. So as ref would go, and right now our node next right here, starting from here, node next is an option of box of node T, right? Just ignoring like all the extra colon syntax.
Yeah.
Option box node that happens to have a T. I wouldn't even worry about the T necessarily. So, an option wrapping a box wrapping a T, and then as ref winds up giving us this same signature. It would be an option of a reference of a box of T. Or sorry, a reference of a box of node.
Okay.
Because that's what the as is. So basically, it gets the borrowing in front or happening. And which would mean that this. Okay, so we do that. And when we map over that thing, it takes ownership of that original option. That's it taking itself. And in here we have next, which happens to be a borrowed box of node T. So we have what this returned. And to dereference, we use one splat. So here like that.
Yeah.
And so if I do that, and then it'll yell at me. So I'll start here. So if I do this, at first it'll say it found the type of a borrowed box node, right? Is what it was looking for, and it's expecting a borrowed node.
Yeah.
So if I go and say do that, and I run it, Now it's no longer a borrowed box of node. It's just a box node. It dereferenced that borrow.
Okay.
And then I do it again on the box, which is a smart pointer. Because a box is a pointer. Like, it's a struct that holds a pointer to something on the heap.
Okay.
Now I have a node that's coming out. Like, it is an option of node, but it wants a borrowed option of node, is what it expects. And then we go and put the ampersand in front of it.
Nice.
Yeah, like, I still don't have super high confidence in that. Like, I see the transformation, but I need to churn on that for a little bit.
Yeah, it's different.
But let's see if we can do this really quick. So we should, like, since we have an iterator, we also should get the other nice benefits of that. So if we have we do an iterator, and I don't know, let's like filter on it or something. I mean, I certainly expect it to work because Rust has filterable stuff. But
Yeah.
either way, I'll push a couple things onto the list. 33 and 1. And if I have an iterator, then if I were to say that I want to filter that, I'm going to filter.
I want to filter out anything over 30. You shouldn't trust any numbers over 30.
All right. So filter out anything over. Is that including 30? Like, is 30 trustworthy?
No.
No? Okay.
Well, yeah. Yeah, 30 is okay.
Okay. Then,
it's on the edge.
Yeah. Okay, so I do that like that. Then I would expect the things that come back.
Just one.
Expected and type. What? Let's see. What is expected reference? Oh man, this is awesome. Like, for as good as I felt the last time, this is good.
Yeah.
Yeah. All right. So, and it doesn't give me type information. What I've noticed is, like, in here, filter doesn't give me a whole lot. All right. So let's look at iterator filter real quick. Or I guess iterator filter, that right there.
Yeah.
Because that should help. All right. So it takes an iterator with a predicate. And let's see, its predicate is p, where p is function immutable, so which I know that is like a closure. It takes a reference to each item, and I guess they have like x is positive, but let's see if we can do that.
Looks like maybe you should put an ampersand in front of your I coming into that filter function.
And enter in front of
They're not doing it. They're not doing it there, but maybe you could put an ampersand in front of that.
Because the closure past the filter takes a reference, and MIDI iterators iterate over references, this leads to a possibly confusing situation where the type of the closure is a double reference. It's common instead to use destructuring on the argument to strip away one. Okay, well.
Yeah, you can also take a look at the chat, and Marupo, if I'm saying that correctly, is helping out.
My chat is just kind of lagging, apparently. Hey, look at that. Awesome. Yeah, for whatever reason, I'm on my phone. Like the chat is super behind.
Huh.
But all right, so yeah, we'll go and do that. Because it's common convention, I guess. And so now we have a reference to a reference, and we'll dereference this. So we have I, which gets us our actual number, and then we'll say greater than or equal to 30. And wait, we only want less than or equal to 30.
Right.
We almost got the big numbers. All right. So now we should get 1 and 33, and I'll actually put this later at the back of the list too.
Well, we won't get 33. Maybe you should change it to 20.
Oh.
29 or 30.
Yeah, 29. 30. Okay. And that should wind up giving us 1, because that is at the head of the list. And then we should wind up getting
30.
Yep, 30, and then 29, 29, and then empty. Aha, awesome.
Nice.
I
think that's kind of weird for a linked list, but I guess that works.
No, to do it in reverse?
No, I mean, it's just weird to do a filter, but, you know, iterable just gives you so many things, so...
Right. Well, I mean, why not? We have, like, I guess if as long as you implement the one next method, you get all the perks of the other ones.
Mm-hmm.
That's good to learn about filter, that you wind up getting a reference, and if you happen to be iterating over references, then that actually, I mean, it does make me curious. On our double star thing that we're doing right here. Like,
yeah.
Can we do this? Or will it not work?
No.
Dang
it.
Wait. It says ref.
So? Ref.
Nope.
No.
It's worth a shot.
Yeah, I mean, once you have it working, you might as well play around with it, right? You can always just undo.
Exactly. Like, I know that I didn't screw anything in addition on. Okay, and I guess we'll get rid of Phantom Menace, too, because we don't need that anymore.
Oh, yeah. Yeah, get rid of that guy.
They worked out, helped us out.
Hopefully that guy doesn't ever show up again.
Yeah, we don't want to deal with that. Okay. Well, I think that's all that I want to overcome for the night. It was definitely more of a battle because of the whole like lifetime thing, and like making that work.
Yep. Yeah. You said we weren't going to get into it, but we did.
Yeah, the compiler forced a hand, and now I know a little bit more about it, or like at least was able to describe it again to you. I guess
compiler was like a grumpy old man that forced you to learn something.
Yeah. So in the terms of, have you ever seen listen to that podcast Reply All?
Yeah, from Gimlet Media.
Yes. So you know where they have a segment called Yes Yes No.
Yeah.
So here is the challenge for you, or maybe like, do you understand, or could you try and describe what lifetime is, like what a lifetime argument is?
Okay. So you name a lifetime, some variable. I guess A is common, right? You start with A unless you need to go to B or C, and you say this variable is going to stick around for as long as something else, and then it will get destroyed as soon as that something else is destroyed. The syntax is where I'm more confused.
No, okay, like what specific syntax? Just
so I don't know how you are actually tying the lifetime of one variable to another. I think you were saying we were tying it to self, but I don't see that in syntax anywhere.
Oh, inside of here?
No. I
So
think you said
yeah. I mean, I did it up.
that as long as self was around.
So
Then
I did it
yeah.
up here with like the peak,
Oh,
where
yeah.
like this is the implied thing that by the compiler, or like the magical thing done by the compiler, and I think, um, like it's. I mean, it's a standard behavior, so it's not really that magical. It's just, um, it's what
I mean,
it takes
it's
care of for us.
programming, so
Yeah,
it's not magical, right?
right. Like I mean, it's not magic. I should stop using that word because like that's
do
bad for.
do you mean like delightful or like
It's
unexpected?
implicit. Maybe that's
Oh,
like
implicit, yeah.
yeah.
Like Ruby on Rails does a lot of implicit stuff. Like it does a
It,
lot of magic.
don't use the M word. Yeah. So my maybe probably incorrect takeaway at the moment is that um, the fact that I'm borrowing this out and the return type of this thing happens to say it has a lifespan of A means that its reference is going to live, or its lifetime is going to be as long as that of self. So given like this option here is ampersand A, then that is also ampersand A.
Okay,
Like,
so kind of the syntax is you put ampersand, I mean, not ampersand, you put quote A in front of a variable, and then you somewhere else you put quote A in front of another variable, and it ties those two things together.
yeah, like as an argument, and then also in your return type.
Okay, so it has to be like in the function definition, like in
Yep.
your argument and return type.
Mm-hmm. But it is implied when you say that.
Yeah.
That continues to do the same thing. So, like, it makes me wonder if here, like, that is the same thing that's happening here. Like, so this right here, this next. Yeah, so right here, do you see where this has the lifetime of A?
Oh yeah.
So, just, yeah, it's an option of lifetime A, no T. And likewise, like the value that comes out of this, I wish I could hold it over the whole thing, but no T. So this should also be borrowing with lifetime of A, meaning that like it's going to live as long as this iterator.
Okay. Well, here on line 50, I don't know what that syntax is. You're doing quote A, but then you're putting your comma after it. What is the
On
comma?
line 50. Oh, because
Yeah.
it's two separate arguments. One is the lifetime. One is the T, which is the T.
So the
like being the
first argument is the lifetime.
I mean, you could potentially have more, but yeah, like it's a different type of argument, and I think the single tick and I don't know, lowercase letter maybe determines the difference of them.
So a lifetime is like a variable you can pass around?
I mean, like a type argument, much like T. I mean, T is not a variable, so like I guess not using it as a variable is necessary because you can't use like T directly inside this code. It's part of the type information of it.
Okay. Cool. Yeah. I want to learn a little bit more just on my own, more about the Rust syntax.
Okay.
Today I just started reading the Wikipedia article about it.
Cool. Um, yeah, I know. Like, I once worked through that too many this thing. It's a good discussion on it. The learning Rust
Too many lists.
with too many linked lists. So it walks through some stuff. So I would say check this out because they walk through the failures, as you kind of saw, where they're like, this should do it, and then it doesn't. And
Yeah. So it reminds me of those books or articles about that will say like learn Rust the hard way.
yep,
And they teach it by having you run into all the problems.
yeah, that is one thing I think or this helped a little bit with, and is like looking at what the compiler is telling you and not getting terrified of it, and instead like trying to decipher what it means. And
Yeah, like you have to learn what the compiler is trying to tell you.
yeah, I think that's true of any compiled language. Rust just happens to have some things that are even like it has more constraints on it because of its like lifetime handling that it has to do in an ownership model that you wouldn't
Yeah.
see elsewhere. Because I mean, I've worked with static languages before, but I mean this like Rust specifically tends to be more errors that I don't know quite how to deal with. But I do know that when it does compile, that like it's going to be safe, assuming that I'm not working with unsafe blocks. Like it improves my confidence a little bit that I'm not doing something horribly wrong.
Yeah, yeah. Cool.
Yeah.
Well, next time, I don't know. We could continue doing a little more Rust next time, maybe a different data structure. But we also talked about doing some work on Orbit FM website as well.
I'm cool with that.
Yeah. So I think we can knock out several low-hanging fruit issues in an hour or so.
Yeah, it may be more exciting than watching me fumble with
And
the compiler. But
Yeah. And we're both very familiar with React, but you haven't seen much Gatsby, I think.
No, I haven't done a lot of work in Gatsby. So yeah, it would be kind of fun to go and switch it up to do that. And then maybe one day our paths will converge on writing WebAssembly to run on Orbit FM, because we'll do like audio manipulation in the browser or something.
Yeah. Actually, I think there's some audio stuff we could do today. Well, I mean, not today, but with today's technology, I think there's a way to download the audio starting at a specific timestamp. So, right now it has a persistent audio player on Orbit.fm, and if you navigate around the site, it'll keep playing. And
yeah,
or if you click, but here's two issues. If you refresh, you won't have the player anymore. It'll just be gone.
Right.
And the other thing is, if you start playing audio by clicking on a timestamp, it has to download all of the audio, even though you want to start like partway through. So it would be nice to like save a cookie or something, a local storage of where you are, in case you hit refresh. And then anyway, when you start playing an audio, if you want to start in the middle of the audio, it could download starting there.
Yeah,
I think there's a way to do that.
That would be kind of cool. I think that'd be fun to play with. We'll have to come up with a plan of action next time and jump on that.
That's not even one of the issues that I have in the issue on GitHub.
Yeah,
it's just something I've been thinking about.
Cool. Well,
cool.
I guess with that, I will take the stream to an end. I appreciate anybody who stopped by or who is listening. Appreciate Mirupo. It was way helpful with calling out things that we could go and try as we struggle through it. And yeah, we'll have to
thanks.
hop on again soon.
And we are planning on doing this every other Thursday.
Yeah, yeah. The Tuesday thing is because I don't work tomorrow, and just I had a free night. So yeah,
Yeah.
every other Thursday when we're not doing Book Bikes recording, we'll have to definitely do this. I enjoy it. So
Cool. Talk to you later, or well, we'll end the stream at least.
yeah, I will end that. So um, if OBS will come up, maybe it will. Oh my no. Well, we can't end streaming. There we go.